1970 Volkswagen Convertible, Restoration Number 2. Clip 42, Electrical Schematics, March 2012. After removing the wiring in clip 22 and reinstalling the wiring in clip 24 and installing the lights in clip 33, you should have a good understanding of the electrical system. But there are some key electrical facts that I should point out. The VW has a 12-volt negative ground system with a generator. My 1970 VW was one of the last VW with a generator. A generator does not put out as much current at low idle speed as an alternator, but a generator car can be pushed off to start. Red wires are called terminal 30 wires and are always hot. Black wires are called terminal 15 wires and go through the switch. I label the wire flow direction beyond the switch with green arrows. I label quick disconnectors with letters such as B shown here. This is the MNB nomenclature, and we will not find this on any other wiring diagram, but it helped me to locate the particular connector. Brown wires are ground wires connected to the body or frame. Black and orange wires are brake light wires. Additional wires will be discussed later. Some other nomenclature items to be shown on the diagram are shown here. And others are shown here. Volt is a measure of voltage and measure how fast electricity is flowing. Amp are a measurement of current and how much volume is flowing through the wire. This is a view of my 1970 Volkswagen electrical system with all the parts labeled, including the quick disconnector connection that I labeled in blue letters. The front of the car is to the top and the rear of the car to the bottom. The main wiring harness is shown here. You may remember this view from earlier. The main wiring harness is shown, along with accessory wiring added by myself. This is a view of the main wiring harness in the trunk. This is a view of the main wiring harness shown with some of the other key wires in the trunk. This is the lower half of the total stock wiring diagram. The main wiring harness shown again. The diagram will be useful in understanding the wiring of a 1970 Volkswagen. This is the upper half of a total stock wiring diagram. Power to the starter. Electricity flows from the battery to the voltage regulator, then to terminal 30 of the light switch. The light switch serves as a junction box for the entire electrical system. Current flows out of terminal 30 of the light switch to key switch 30, and then out of the key switch terminal 50 through the quick disconnect labeled as F, then to the starter solenoid. The starter ground completes the circuit. Power to the coil is shown here. Electricity flow to the switch in the same as the starter, but this time flow exit terminal 15 side of the switch to fuse 2 inside. Electricity flows the green path out of fuse number 1 inside to the coil plus 15 terminal as shown. This is a blow up of the coil. On the plus 15 side, you have the hot wire from the switch, you have the wire to the backup fuse, you have the wire to the choke and pilot jet, and then you have the red wire to the distributor with electronic ignition. On the negative side, you have the wire to the tach that I added, and you have the black wire to the electronic distributor. Then of course you have the main coil wire coming out of the center of the coil going to the distributor cap. While we're here, I will discuss how the timing light and dwell meter hooks up to the coil. On the timing light, the number 1 spark plug is connected to the black wire. The red wire connects to the number 15 terminal on the coil, and the black wire connects to ground. On the 12 meter, the black wire connects to ground, and the green wire connects to the negative terminal on the coil, as shown. The procedure for using the timing light: the vacuum hose off and plug, the RPM set for 850, and read 0 degree top dead center on the left mark on the flywheel. The procedure for 12 meter use is: set the unit on dwell. The 8-cylinder scale will read half or 26 degrees. The 4-cylinder will read 52 degrees. Power to the spark plug is the same as discussed, but this time power passes through the coil and out the coil wire in the center as shown, to the distributor and to each spark plug per the revolution of the distributor. Power to the fuse box is from the light switch terminal 30 as previously discussed. The light switch terminal 58 provides power to the inside of fuse 7, and light switch terminal 30 also provides power to the inside of fuse 9 as shown. Power to the generator. Power from the battery enters the B plus terminal and traverses the voltage regulator D plus terminal to the generator D plus as the main charging wire. Also, power from the DF terminal of the voltage regulator provides current to the DF generator field. Voltage regulator terminal 61 blue wire connect to the generator charging light. This is a blow-up of the voltage regulator depicting the wires previously discussed. This is the rear portion of the headlight and tail light circuit. All lights are shown on. The black wire is the turn signal. The gray and red wire are the tail lights and brake light. The blue wires are the backup light. The tag light is shown as the red and gray wire. This is the front portion of the headlight and tail light circuit. Again, all lights are shown on. The low beam headlights are shown in yellow, and the high beam headlights are shown in pink, which actually they are white on the Volkswagen. The left and right side of each high and low beam are on separate circuits. The dimmer relay blow-up J is the switcher between these circuits. The other blow-up shown is the light switch. This drawing depicts the headlight circuit only and shows the internal switching blow-up of dimmer relay J. This drawing depicts the tail light circuit only and shows the internal blow-up of the tail light wiring. This drawing depicts the rear parking light circuit only, along with the tag light. This drawing depicts the front parking light and side marker circuit. This drawing depicts the brake light circuit along with the blow-up of the master cylinder brake switches. This drawing depicts the backup light or reverse circuit. The backup light switch is located on the transmission as shown here. This drawing depicts the front portion of the flasher or turn signal circuit. Power from the switch terminal 54BL is supplied to the flasher relay J. The flasher relay wire connects to the emergency flasher and then turn signal warning light. Turning left, the black and white wire provide power to the left side light. Turning right, the black and green wire provide power to the right side lights. This drawing depicts the rear portion of the flasher or turn signal circuit. Turning left, the black and white wire provide power to the left side light, and turning right, the black and green wire provide power to the right side lights. This is another drawing that depicts the flasher or turn signal circuit and a blow-up of the emergency flasher relay J2 and the emergency flasher E3. This drawing depicts the dome light and key buzzer circuit. Power is applied from the downside of fuse 9 to the dome light. Door switch F2 driver's side door and F3 passenger side door control the light ground. This drawing depicts the key buzzer circuit, which is a portion of the dome light circuit previously discussed. Also shown is a blow-up of the key buzzer 8.5. Power is supplied from the downside of fuse 9 to the key buzzer. Door switch F2 on the driver's side door and F3 on the passenger side door controls the buzzer ground when the key is in the switch. This drawing depicts the wiper circuit. Power is supplied from the downside of fuse 2, green wire, to the wiper switch terminal 30. The same terminal also provides power to the emergency flasher light K7. Various wires from the light switch traverse to the windshield wiper motor as shown. A blow-up of the windshield wiper motor is shown as well as a blow-up of wiper switch E. This drawing depicts the horn circuit. Power is supplied on the downside of fuse 1 to the horn. The ground is provided through the steering wheel shaft to the horn button on the steering wheel. This drawing depicts the fuel gauge circuit. Power is supplied from the downside of fuse 1 to the fuel vibrator. The fuel unit provides the ground back to gauge G1. This drawing depicts the oil pressure light circuit. Power is supplied from the key switch and ground is provided from the oil pressure sending unit through the green-blue wire to the K3 bulb on the instrument gauge. This drawing depicts how the accessory gauges connect to the stock electrical system. The tach, the dark green wire control, is provided from the coil negative terminal. The oil temperature blue wire is not presently connected. The oil pressure light green wire is connected to the oil pressure sending unit. The voltmeter black wire is connected to the downside of fuse 1. The 12-volt accessory plug red wire is connected to the downside of fuse 9. This drawing depicts the internal wiring of the M&B added accessory gauge, not stock, on my 1970 Volkswagen. The view is from the trunk. Brown wire connect to the common ground on the gauges. Black wire to each gauge connect key switch power from the downside of fuse 1. Red wire is power to the internal gauge lights on the various gauges. The wire denoted with an orange circle all traverse the engine through the wire conduit tubing on the floor pan as previously discussed. These are the speaker wires again. These are the wires that hook up to the back of the radio. This is the radio schematic. This is the ISO connector to the back of the radio. This is the view of the fuse block from the trunk and from under the dash. A summary of the fuse sizes and location of a 1970 stock VW. The red items are non-stock items that I added to my 1970 VW. And that is absolutely everything I know about the wiring on my 1970 VW.